Hi, today's lesson's on graphing rational functions. So one of the easiest ways to rewrite our graph rational function is to write it in basically transformational form or vertex form or whatever you want to call it. So we can use that using long division, which we learned from the previous unit. So if I go x minus 3 and then 4x, I'm going to add a 0 to it just so I have the same amount of terms. Now we divide this by this, which is 4. So we get 4x minus 12. Do the opposite. So we can rewrite this as 4 plus 12 over x minus 3. Now, if you notice, this is our same function. So what we can do is just find the center, which is going to be 3, 4. So go to 3, 4. Do your asymptotes. And since 12 is positive, we're going to go low, high. And that's basically how you graph it. And it's just a quick sketch, but that is probably the easiest way to graph these. Go ahead and try this problem. Now, one of the key things to graphing is find the asymptotes. Now, when it's in that transformational form, the asymptotes are just there. They're part of the numbers in the problem. But what if it's like this? What if it's a little more complicated? So what makes a vertical asymptote is it's what makes it divide by 0. So the way we find the vertical asymptote is we take the bottom and we set that equal to 0. So if we did that, we get 3x minus 2. First we got to do is factor the bottom. So x plus 3, x plus 4. If we set that equal to 0, we get negative 3 and negative 4. And those are your vertical asymptotes. So we have vertical asymptotes at x equals negative 3 and x equals negative 4. Go ahead and try this problem. All right, what if we want to find horizontal asymptotes? With horizontal asymptotes, it all depends on the lead term of the top and the bottom. So what we're going to do is we're actually going to divide these two. So, but before I get there, let me go ahead and show you basically what happens. So, or what the cases could be, I guess. So we're going to divide the lead term of the top and the bottom. We have three cases that can show up. The first case is there's an x on top. If that's the case, then there are no horizontal asymptotes. Next thing you could have is the x's cancel. In other words, there's no more x's at all. If that's the case, then your horizontal asymptote is y equals whatever number you're left with. And the last one is x is left on the bottom. So in other words, there's an x left on the bottom after you're done. That's automatically y equals 0, no matter what. So these are the three cases that show up. So let's go ahead and try this problem right here. So take the leading term on the top, which is 3x, divided by the leading term on the bottom, x squared. If we divide this, we get 3 over x. Since x is on the bottom, you get y equals 0. So for example, what if it's left on top? What if I have like 2x to the fourth over x to the third? That would give me 2x on top So there'd be none. All right, what if they cancel? So if I have like 4x to the third over 2x to the third, and I get 2, that's your answer. Y equals 2. So whatever you get here. Could be a fraction, could be whatever. Go ahead and try this problem. Okay, let's go ahead and try graphing this one in this form. One of the key ways you could do this is do long division and rewrite it, but it's kind of messy with the fractions. But let's do it. Let's graph this using the asymptotes. So if we take a look, first let's find the vertical asymptote, which is just set the bottom to 0. So that means our vertical would be x equals 4 over 3. And then for our horizontal, we do the trick we just learned. 2x divided by 3x would just be 2 over 3. So y equals 2 over 3. So that means we have a center at 4/3 and 2/3. So if we go ahead and graph this, so 4/3 would be 1 1/3. So that'd be right here. 2/3 would be just under here. So it's right around here somewhere. Now all you gotta do is draw your asymptotes. Now we cannot determine from this whether it's positive or negative. So we have to use a test point. My favorite test point to use is the y-intercept. So the y-intercept is when x equals 0. So in other words, what that means is you literally just cancel out the x's. So whatever constants are left, that is your y-intercept. So 1 over -4. So my y-intercept is -1/4, which is right here. And since it's in this quadrant, formed by this, we basically get a graph that looks like this. And since it's in this quadrant, it's always catty corner from or opposite of it. If it was up here, you go downward. So this one's positive because this one started low. If it was up here, it'd be negative. Go ahead and try this problem. All right, to graph something a little bit more, we do the same exact steps. So we first find the vertical asymptotes, which is done by factoring the bottom. So we get x plus 5, x minus 3. So my vertical asymptotes are x equals -5 and 3. And so I'm going to go ahead and use this graph right here, this section, to graph this. So -5 would be 1, 2, 3, 4, 5. So you got a vertical right there. You got 1, 2, 3, vertical right there. And now to find the horizontal asymptote, all we do is divide the first two. We're left with 4. So y equals 4. So it'd be 1, 2, 3, 4. So we get something in this format. Now doing the same thing with the y-intercept. The y-intercept will be -9 over -15, which is positive 9/15, which is in here somewhere. So basically we get a graph that looks like this. And the way it works is once you get the center here, it's the opposites here and opposites there. Go ahead and try one.